All right, so let's do another example here. They're giving us two different lines. We have to classify if these lines are parallel, perpendicular, or neither. And the way we do that, once again, is by looking at the slopes. Okay, so the way this first line is written, we can't exactly tell what the slope is yet because it's in standard form. But for the second line, it's in slope-intercept form. It's in the format y is equal to mx plus b. So if we look at what m is equal to, it looks like m is equal to 3/4. So the slope of the second line is going to be equal to 3/4. Okay, now all we got to do is we got to figure out what is the slope of this first line, and then once we determine that slope, we will tell if it's parallel, perpendicular, or neither. So we want to get it in slope-intercept form. We want it to make it look like y is equal to mx plus b. So let's go ahead and do that. Let's isolate y. Let's get y all by itself. So the first thing I'll do is I'll subtract 4x from both sides. And I'll be left with negative 3y is equal to negative 4x plus 9. And then to get y by itself, I need to divide my entire left side by negative 3 and my entire right side by negative 3. So what that looks like is I basically just divide both pieces by negative 3. It's the exact same thing as dividing the entire right side. So what I'll be left with is y is equal to negative 4x divided by negative 3. So if I have a negative divided by a negative, the negatives essentially cancel, and I'm just left with positive 4/3 x plus 9 divided by negative 3. 9 divided by negative 3 should be minus 3. Okay, so this is the equation in slope-intercept form of the first line, but really what we're just looking for is we're looking for the slope. And the slope of that first line is going to be positive 4/3. Okay, so now that we have the slopes of both lines, we look to see, are these parallel, perpendicular, or neither? So parallel, they got to be the exact same number. These are obviously not the exact same number, so they can't be parallel. To be perpendicular, they need to be opposite reciprocals, okay? So if we look, it is true that 4/3 is the reciprocal of 3/4, but we notice here that both of these guys are positive. They don't have opposite signs, okay? To be perpendicular, you need two things. You need to be opposite and you need to be reciprocal, okay? One of those conditions is not met, so it's not perpendicular. So if it's not parallel and it's not perpendicular, it's going to be neither one of those things. Okay, they do intersect, but they're not going to intersect at a 90-degree angle. This would be neither. Okay, let's do another example. It says, write an equation of the line in slope-intercept form passing through the given slope and is parallel to y is equal to 6x minus 2. Okay, couple things going on here. We want the equation of our second line to be in slope-intercept form. We want our answer to look like y is equal to mx plus b. So we want our line to be written in this format, and we want it to be parallel to this one, but we also want it to pass through the point 1 comma negative 3. Okay, a couple different conditions we need to meet here. Okay, but the first thing we need is we need whatever this line is, we need it to be parallel to y is equal to 6x minus 2. Okay, what is the one condition we need if it's going to be parallel? It means it's got to have the exact same slope as this line. Okay, so we know if the slope of this line they're giving us is 6, we know that the slope of a line that's parallel to it should also be 6. Okay, it's going to have the exact same slope as this line. Okay, that's the first condition. This line is going to have a slope of 6. But the other thing it's got to do is it's got to pass through this point. So what are they giving us? They're giving us a slope and they're giving us a point. Okay? Remember, my end goal here is to make sure it's in slope-intercept form. But what we could do right now is we could just write our equation in point-slope form. Y minus y1 is equal to m times x minus x1. And then ultimately convert it to this format. But let's plug these numbers into this equation. So what I'll have here is I'll have y minus y1. My y coordinate here is negative 3. Minus negative 3 becomes plus 3. And that's equal to my slope, which is 6, times x minus x1. My x coordinate here is just positive 1, so I should have minus 1. Okay, so I wrote the equation of the line I'm looking for in point-slope form. Now all I gotta do is convert it to slope-intercept form, make this look like that. So I want to get y by itself, and if I want to isolate y, my first step should probably be to distribute the 6 to both pieces. I'll have 6x minus 6 on the right, y plus 3 on the left, and to get y by itself, all I gotta do is subtract 3 from both sides. And I should be left with y is equal to 6x minus negative 6 minus 3 is minus 9. It's in slope-intercept form, and it's got that exact same slope, so we know it's parallel.